we are discussing fuzzy clustering algorithms. Now, we have already explained the working principle of fuzzy Siemens clustering with a suitable numerical example. Now, we are going to start with another very popular algorithm, which is known as entropy based fuzzy clustering algorithm. Now, here we are going to use a term that is called the entropy, and which is nothing but an index. Now, this particular index is used just to identify which one should be the cluster center. Now, supposing that we have got a large number of data points in multidimensional form, and our aim is to identify who should be the cluster center. Now, what we do is we use the concept of, so this particular the entropy, and this entropy value if you want to calculate, we will have to take the help of one value that is called the similarity value, and similarity is based on the numerical value of Euclidean distance. Now, supposing that I have got 2 points, say point I and another point, say point j. So, very easily I can find out what is the Euclidean distance, and that is denoted by d I j. And if I know the Euclidean distance, so I can find out the similarity between these 2 points, that is denoted by s I j. Now, if the distance between the 2 points is more, the similarity will be less, and vice versa. And as I told, once you have got this particular the Euclidean distance, we are in a position to calculate the similarity, and if I know the similarity information, so we can find out. So, this particular entropy, and I have already mentioned that this particular entropy is an index which help us to decide which one should be the cluster center. Now, the point which is having the minimum entropy value is selected as the cluster center. Now, once you have got this particular cluster center, supposing that I have got this is the cluster center. Now, surrounding this particular cluster center, we have got a number of data points. Now, we will have to take one decision. So, out of all the data points which are going to enter, so that particular the cluster. Now, what we do is we try to take the help of similarity once again, and there will be some threshold value of similarity. Now, the data points surrounding this particular cluster center, which are found to have similarity greater than equals to some pre-specified value, will be encouraged to enter this particular the cluster. Now, this is the way actually we do the clustering, and this particular thing we are going to discuss in much more details. Now, here, so I am just going to take one typical example. Supposing that we have got a large number of data points, say capital N number of data points, and supposing that, so this particular capital N is equals to say 1000. So, we have got 1000 data points, and these data points is in a higher dimension, say L dimensional space. That means, if I want to represent, so a particular point, I need to have capital L number of numerical values. Now, what we do is using this entropy based fuzzy clustering, as I discussed, the first thing we do is we try to identify which one should be the cluster center. Now, supposing that we have calculated entropy for each of the data point. Now, how to calculate I will be discussing in much more details, but supposing that we have got the entropy values, the data point which is having the minimum value of entropy, that will be declared as the cluster center. Now, supposing that, say let me assume that this particular data point is having the minimum entropy value. So, this is nothing but the cluster center. Now, the moment we declare that this is the cluster center, now surrounding this, so we will have to find out actually a few members which will also belong to, so this particular the cluster. Now, what we do is, so we try to compare the similarity of the data point with this cluster center. So, how to find out the similarity? So, what we do is we calculate the Euclidean distance, and using the Euclidean distance information we try to find out the similarity. Now, if this particular similarity with respect to the center of the cluster, if it is found to be greater than or equals to some threshold value denoted by beta, then we allow those points to lie within this particular the cluster. So, this is the way actually we do the clustering using the entropy based fuzzy clustering. Now, I am just going to discuss in much more details. Now, let us consider that we have got capital N number of data points, and these data points are in L dimensional hyperspace, and our aim is to actually carry out this particular clustering. That means, we will have to divide these data points into a few clusters, and these clusters will be fuzzy clusters. Now, we take the help of a few steps. Now, step 1, we arrange the data point in n rows and n columns, L columns. So, n rows means I have got capital N number of data points, and each data point is having L dimension, that means L numerical values, and so we take the help of one matrix, and its dimension are actually n cross L. So, there are n rows and L columns. Now, step 2, we calculate the Euclidean distance between the two data points I and j. So, using this particular well known formula. So, d I j is nothing but square root of summation k equals to 1 to L x I k minus x j k square. It is very simple. Now, here k varies from 1 to L, L is nothing but the total number of dimension. Now, here we consider, so k equals to 1 to L, and I have got 2 points, one is your I and another is your j. Now, dimension wise we try to find out the difference, square of them, and after that we add them up and we take the square root of that. So, this is the way we calculate the Euclidean distance between the 2 points I and j. Now, once you have got the Euclidean distance between the two data points, now actually we will have to find out what is the similarity among them. Now, as I told that if the Euclidean distance between the two data points is more, so their similarity is less and vice versa. Now, let us see how to represent so this particular relationship in the mathematical form. Now, in step 3, we try to find out the similarity S I j between the two data points, that is your I and j. Now, the way the similarity and this particular distance relationship has been written is as follows, like S I j is nothing but e raised to the power minus alpha d I j. Now, if d I j is more, then this becomes 1 divided by e raised to the power alpha d I j. So, if d I j is more, so this particular expression is going to be reduced, that means your similarity is less. So, if the two data points are too far, so that similarity will be less and your the vice versa. Now, here I just want to mention that this particular relationship is actually not the unique. Now, I can write down, so this particular relationship between the Euclidean distance and similarity in slightly different way also, but this is actually the method the proposer. So, he used. So, I am just going to use the same expression, that is S I j is nothing but e raised to the power minus alpha d I j, where alpha is a constant and the value for this particular constant is to be determined. Now, how to determine this particular value of this particular your alpha? So, that I am going to discuss. Now, here actually to determine the value of alpha, we assume a similarity of 0.05, when the distance between the two data points, that is d I j, becomes equal to the mean distance of all pairs of data points. Now, let me take a very simple example. Supposing that I have got only 5 points here. So, if I have got only 5 points, what could be the possibilities of the distance values? The distance could be your d 11, then comes d 12, d 13, d 14, d 15, then the distance between 2 and 1, 2 and 2, then comes 2 3, then d 24, then comes your d 25, then comes d 31, d 32. So, d 33, d 34, then comes d 35, then d 41, d 42, d 43, d 44, then comes d 45, then d 51. So, d 52, then comes d 53, then comes d 54, and then comes your d 55. Now, here, so d 12 means what? That is the distance between 1 and 2, and d 21 is the distance between 2 and 1. So, we assume that your d 21 is equal to your d 12. Similarly, d 41 is equal to your d 14, and so on. Now, if we concentrate on the diagonal elements, that is d 11, d 22, d 33, d 44 and d 55. So, these diagonal elements if we concentrate. So, the distance between 1 and 1 or 2 and 2. So, these are all equal to 0. So, distance between 1 1, 2 2 and so on, and that is equals to 0. And moreover, we have already considered the d 21 is nothing but d 12. That means, your if I just concentrate on only one side of this principal diagonal. So, I will be able to find out the distance values. For example, if I just concentrate on these the distance values, that means, your d 11, 13, 14, 15, d 23, 24, 25, 34, 35 and d 45. So, I will be able to find out the distance values. Now, here we consider 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, we consider the 10 distance values. Now, here if I just know these particular 10 distance values, so my purpose is solved, and I need not calculate all 5 multiplied by 5, 25 distance values. Now, this particular 10 is actually nothing but is your 5 C 2, and 5 C 2 if we calculate. So, this is 5 factorial, then comes your 3 factorial, 2 factorial. So, this is nothing but 5 multiplied by 4, that is 20 divided by your 2, and this is nothing but 10. So, if I know these 10 information, so my purpose will be solved. And what you do is, so to determine your the d bar, that is the mean distance. So, we consider 1 divided by n C 2. So, this n C 2 is nothing but 10 here, because here n is equals to 5 according to this particular the example, and then we try to find out summation I equals to 1 to n, summation j is greater than I to n d I j. That means, we consider only one side of this particular the triangle, and this is the way actually we can find out what should be the average the distance values, that is nothing but is your d bar. Now, let me come back. So, we assume a similarity of 0.5 when the distance between the 2 points, that is d I j becomes equals to d bar. So, d I j equals to d bar, and this is nothing but this particular expression. Now, here actually if I just your derive, so I can find out what should be the suitable expression for this particular your alpha. Now, let me try to derive here. Now, the similarity. So, if I just see the expression for the similarity, that was nothing but S I j. So, e raised to the power minus alpha. So, d I j. So, this is the relationship between the similarity and the Euclidean distance, and our aim is to derive this particular the expression for alpha. Now, what we do is we consider a similarity of 0.5. So, 0.5 is nothing but say 1 divided by 2, and that is nothing but is your e raised to the power minus alpha, and this d I j is nothing but the mean distance, that is d bar. Now, if I take log like the log base e on the both sides, so I will be getting ln half is nothing but ln e raised to the power alpha d bar. Now, this can be written as your minus alpha d bar. So, minus alpha d bar ln e, and this can be written as ln 1 minus ln 2, and that is nothing but minus alpha. So, d bar. Now, ln e, that is e log e base e, that is equals to 1, and here log 1 is equals to 0. So, I can find out minus ln 2 is equals to minus alpha d bar, and from here I can find out that alpha is nothing but ln 2 divided by d bar, and this is the expression which I have written. So, I can find out the value, the numerical value for this particular alpha, and once I have got the numerical value for this particular alpha. So, very easily I can find out the relationship between your similarity and the Euclidean distance values using this particular expression. So, this is the way actually we will have to calculate your the similarity. Now, once you have got this particular similarity, now we are in a position to find out what should be the entropy. Now, to determine the entropy, that is the index. So, what we do is we use this particular expression in step 4, and remember one thing. So, this particular expression has been actually designed based on one philosophy. Now, I am just going to discuss the philosophy past, okay, and which is the reason behind defining this relationship between entropy and similarity. So, this indicates actually the relationship between this entropy and the similarity S. Now, let me try to concentrate here, and let us see if I take some suitable value for the similarity, then what happens to the entropy. Now, let me assume that say AC is equals to 0. Now, if I take the AC is equals to 0, that means your similarity equals to 0, that means the distance between the 2 points is actually very high, and the 2 points are too far, and let us see what happens to entropy. So, using this particular the expression. Now, if AC is equals to 0, so what will happen to the entropy? So, E is nothing but minus. So, I am just going to put AC equals to 0, and here if I put AC equals to 0, log 0 is not defined. So, it is undefined, but it is multiplied by 0. So, its contribution will be actually 0. Then comes your minus 1 minus S. So, S equals to 0. So, I will be getting 1 here, then log base 2 S equals to 0. So, log base 2 1, and log base 2 1 is once again is equal to 0. So, I will be getting 0. So, this is nothing but 0. So, if I put S equals to 0, so I am getting entropy is equal to 0. Now, let me put another extreme value for this similarity. Let me put S is equals to 1. That means, your the similarity between the two data points is equal to 1. That means, the two data points are exactly similar, and the distance between them is equals to 0. Now, if I put S equals to 1 in this particular expression, so I will be getting that entropy is nothing but, so minus 1 log base 2 1. So, that is equals to 0. Then comes your S equals to 1. So, this will become 0. So, once again I will be getting 0. So, for S equals to 1, that means when the similarity between the two data point is equals to 1, that means your the Euclidean distance is equal to 0, then also the entropy becomes equal to 0. So, for the true extreme condition, when the similarity equals to 0 and the similarity equals to 1, the entropy becomes equal to 0. Now, let us try to find out when S is put equal to say 0.5 or half. Let us see what happens, because S is in between now. So, we calculate actually the entropy. So, this is nothing but minus half, then comes your log base 2. So, log base 2 half minus, so S equals to half. So, this will become half, then comes your log base 2. So, this is nothing but half. So, this can be written as your minus log base 2 half. So, this is nothing but is your minus. So, log 1 base 2 minus log 2 your base 2. Now, log 2 base 2, that is what the log 2 base 2. So, this is actually your 1 and your log 1 base 2. So, this is equals to 0. So, I will be getting minus 1 here and I have got here minus. So, this minus and minus. So, this will become equal to plus 1. So, entropy becomes equal to your 1. So, when similarity is 0.5, so entropy becomes equal to your 1.0. So, based on this particular philosophy, so this relationship has been derived. Okay. And once you have got this particular thing, so now we are in a position to find out the total entropy for each of the data points. Now, we have got capital N number of data points. So, for each of the data points, so I will be able to find out what is E I, where I varies from say 1 to up to your n. So, for all the data points, so I will be getting that particular your the entropy value, that is the index value. And to calculate the total entropy, actually this is the expression which I will have to use. So, E I, that is the entropy for the ith data point, is nothing but minus summation j belongs to x, j not equals to I, then comes your within bracket S I j log base 2 S I j plus 1 minus S I j log base 2 1 minus S I j. So, this is the way actually we can find out what should be the total entropy for each of the data points. And once you have got this particular the information of the total entropy for each of the data points, now I am in a position to give statement of the different steps of this algorithm. So, we are going to discuss the steps to be followed in this clustering algorithm. Now, step 1, we calculate entropy E I for each of the data point x I lying in T hyperspace. So, as I told, we have got capital N number of data points in L dimension. So, all such data points I am just going to represent by T hyperspace data points. Okay. Now, what we do is, so we try to calculate the entropy, the total entropy for each of the data points, the method which we have already discussed. And once you have got the whole information of this entropy for all the data points, now we are in a position to identify a particular data point which is having the minimum value of entropy. So, step 2, we identify x I that has got the minimum entropy value and we mark as x I minimum, and that is declared as your the cluster center. So, we declared, so that particular your the cluster center, so which is having the minimum value of your entropy. And once you have got that particular cluster center, in step 3 actually what we do is we put x I minimum and the data points having similarity with x I minimum greater than your beta, and beta is nothing but the threshold value of similarity. So, the user is going to define what should be the threshold value of similarity For example, say this could be 0.6, it could be 0.4, it could be 0.8 and so on. And what you do is, so we have got this particular cluster center, and surrounding this we are going to define one cluster. So, what we do is, the data points which are having similarity with this cluster center greater than or equals to this the threshold value. So, those are allowed to enter to this particular the cluster. So, finally, I will be getting this particular the cluster. So, let me repeat, in step 3 we put xi minimum and the data points having similarity with xi minimum greater than beta in a cluster, and we remove them from your the T hyperspace. Supposing that initially I had got say 1000 data points, and in the first cluster supposing that 300 data points are entering. So, I have got 1000 minus this 300, that is nothing but 700 data points remaining, and with the help of these remaining 700 data points I will try to form the second cluster, third cluster and so on. Now, step 4, check if T is empty. If it is yes, you terminate the program. That means, all the data points have been put some clusters, else we go to step 2. That means, we repeat from step 2 to step 4. So, this is the way actually we do the clustering using the entropy based fuzzy clustering. Now, here I just want to tell you that this clustering algorithm is very flexible, and if I just change the value of this beta little bit, there will be actually too much change in the obtained cluster, and that is why. So, this clustering algorithm is very flexible. Now, here I am just going to discuss one concept, that is the concept of outlier. Now, actually if you see, so supposing that say I have got 1000 data points, and these 1000 data points have been say divided into a few clusters. For example, say this is one cluster, this is another clusters, this is another cluster, this is a fuzzy cluster. So, there could be overlapping also. So, there could be another cluster, say C4. Now, what we do is, we try to count the number of data points present in each of the clusters. So, we try to find out, so how many data points are there in the first cluster, that is C1, the second cluster whose center is C2, that number of data points in third cluster, number of data points in fourth cluster. And supposing that, so these 1000 data points have been actually clustered into 4 clusters, and we know how many data points are present in each of the clusters. So, after that actually what we do is, we try to define whether all the clusters are valid clusters, or there could be a few outliers. Outliers means actually those data points which do not belong to any of the clusters. So, what we do is, we try to count the number of data points present in each of the clusters, and if that particular data point is found to be greater than or equals to gamma percent of the total data points, then we declare that this particular cluster is a valid cluster. Now, if I take say gamma equals to 10%, that is 1/10, that means 10%, that is 1/10 of your 1000, that is nothing but your 100 points. That means, to declare a particular cluster a valid one, there must be at least 100 points in that particular the cluster. Supposing that there are only 30 points in a particular class, so called cluster. So, we define those 30 points are nothing but the outliers, and we in fact do not consider that particular cluster having only 30 points as a valid clusters. Now, this is the way actually we do the clustering, and as I have already mentioned that while doing this particular cluster, so we will have to be very careful regarding. So, this particular cluster has to be very distinct. So, we try to define the distinct cluster. So, the cluster has to be distinct, this I have already discussed. the cluster has to be compact, and at the same time there should not be any outliers. So, the number of outliers should be as minimum as possible. So, our aim is to minimize. So, this particular the number of the outliers, and in ideal condition the number of outlier should be equal to 0, and our aim is to maximize the distinctness, and our aim is to maximize the compactness also. Now, this I have already discussed that to measure the distinctness of the clusters, we consider intercluster distances. This I have already discussed in the last lecture. So, to measure the distinctness, actually what we do is we consider actually intercluster distance, Euclidean distance, and to measure the compactness. So, what we do is we consider the intracluster Euclidean distance values. So, this is the way actually we try to find out what should be the distinctness, what should be the compactness, and we can also measure the number of outliers. And let me repeat, our aim is to reach the clustering which ensure the maximum distinctness, maximum compactness, and minimum number of outliers. Now, this is the way actually we use. So, this particular your the entropy based fuzzy clustering. Thank you.